So I'll tell today about React Native. That's the second time I'm talking about that, and I gave already one workshop at CodePod recently. It's quite cool actually. For the very beginning, how many of you are iOS developers here? No, it's almost everyone. How many of you is Android developers here? Quite a few. How many of you know JavaScript? A lot. How many of you likes JavaScript? Much less. Okay, good. I just wanted to know, like, what should I talk about? So I'll talk about React Native. A few words about myself. If you don't know me, I'm CTO at Polylia. I'm the kind of CTO that likes to get the hands dirty, so I like to play with stuff like React Native is one of the examples, most recent examples. I'm also founder of a small meetup group called Mobile Warsaw. If you don't know the group, you know, okay, good. And I'm founder and organizer of mcconf.com. If you don't know Mobile Central Europe. We already had 2 editions, and the 3rd edition is in preparation. Very soon some announcement will be made about that, but not today. So first I will tell you what React Native is not, because probably you've heard something. How many of you heard about React Native? Good. Almost everyone, good. So some of you might, how many of you tried React Native? 1, 2, okay, good. A little bit, 3. So you might have some misconceptions about what React Native is, and I will explain what it is. Actually, I will explain you what it is not. So first of all, it's not a hybrid app framework. So you are not developing web applications and put it in mobile. That doesn't work, and it won't work with React Native. Won't ever work. So there is no HTML DOM. There is no CSS with a little asterisk. You know, so it's almost CSS, but not quite like. It's not a cross-platform development tool either. So you don't, well, a little bit. You don't develop one application for all platforms. Yeah, it won't work either. Yeah, you have to make different applications. It's not. It doesn't provide you application architecture framework. So you can build any architecture you want, and you can build your application in any architecture. React Native will not force you any architecture. It's just a UI library. I will tell a little bit about that later. And when I started working on React Native, I subscribed to Stack Overflow, and I answered quite a lot of questions already there about React Native. So one of the questions I answered was like, can I use jQuery plugin with React Native? No, because jQuery is very closely tied to DOM HTML, CSS, so you cannot use any jQuery plugins, which is a good thing, by the way. So what React Native is? React Native is a JavaScript library for building user interface. No more, no less. So you can build user interfaces with it, and the rest of the application is not like you do whatever you want, but React Native helps you to do the user interface part. And if you see the small thing, you know the Atwood's law. Any application that can be written in JavaScript will eventually be written in JavaScript. I love that phrase because it's very true. Actually, if you look at anything which ends with .js, you will find whatever is in front of it, and it works, or almost. So this is exactly what Facebook did with React Native. They took a native application, and anything they could rewrite in JavaScript, they rewrote it. Anything they couldn't, they didn't. So this is really like very close embodiment of the Atwood's law. Probably they read it before they started working on it. Again, there is no architecture lock-in. So you have really native UI components that you're working with. So native UI views, basically. The React Native does not force you to do any like two-way data binding, or so binding the data of model with the UI that you are displaying. They will not force you to do any application architecture. It's a fully asynchronous UI and fully asynchronous communication, so it doesn't really force you anything. It like you just tell React Native to display something, and when you act, it sends an event. That's pretty much it. So that's the interface that it has. So it's very easy to plug it in any architecture that you can imagine. And it's very good for modern patterns of application development, such as if you do domain-driven design. There is this pattern of CQRS. I don't even remember what it stands for. Query is the Q. But it's basically pretty much what React Native implements. It's very good for, because it's fully asynchronous and you can send your data to something and get results. Pretty much this. One of the things which work great with React Native is Flags. It's also done by Facebook. And this is architecture pattern that you can apply to React Native, and it works very well, again, because it's asynchronous. And it's really good. But you can pretty much use anything regarding application architecture. So what is React Native? You might ask in a little bit more detail. So React Native is really all about components. So it's very, very component-centric. So you develop components, something that you put on screen, small piece of something that you display. That's the component. But what React Native imposes on the component is like every component is its own state machine. So it's not a state machine of the whole application. It's a state machine of this particular component. This is very important. Every component has a state. There are some transitions between the state. And there are some properties that this component has. Pretty much normal, like any other UI component you can imagine. I actually, 20 years ago, I worked with Delphi, and there were components with properties as well, so it's the same. Nothing changed since then. Every component has its render method, which uses something called JSX. I will tell and show you a little bit about that in a moment. There is a Flexbox. Do you know Flexbox? You know what Flexbox is? It's a some people nod their heads. Yeah. So that's a nicer way of laying out components on web, on HTML. But it's actually used in Facebook. In React Native. It's a little bit like CSS, but you can style your components and you can lay them out with the styling. The components are also composable. So you can put many components inside other components, and you can build bigger components with the smaller components. And application consists of components, and it's like big tree hierarchy. Pretty much standard. Nothing pretty special so far. Demo, short one. I will run a small application which I wrote for CodePod. This is the workshop I was talking about. It's a very complex application, as you see. You can click and there is something changes. Very, very complex. And I'll show you in IntelliJ presentation mode how the code looks like a little bit. So there is the component. It's just a class in JavaScript if you don't know it. It has some initial state. As I told, the component has a state. It's a state machine. Some lifecycle methods, some action methods that you can call. This is a view. This is how it actually renders itself. So it displays, and that's becoming a little bit, for those of you who knows JavaScript and do not know JSX, that's becoming a little bit scary because, well, we are mixing a little bit of JavaScript with some kind of XML. A little bit strange. But that's how it works. I will tell about that a little bit later. So there is this render methods. What's interesting here, depending on state, you display different, you render the component differently. That's very important for React. So you have the state that describes the component, and depending on the state, you either have initial state or clicked state, which you can actually see here. That's the initial, that's the clicked state. Yeah? So that's the initial state here. Sorry. 2 components here, 2 images, and that's the click state here. That's pretty much it. What's else also in this file? That's also for those of you who knows JavaScript and CSS a little bit. They are styles. They are telling you how your images will look like, how your background will be. Very similar to CSS if you know it. But what's scary for some people, it's like it's in the same file. Yeah, that's, wow, what? Okay, yes, it is in the same style, and it's good. There is some presentation, there are some good presentation about that. But that's basically it. That's how a React Native component looks like. Object with some methods, render, some style, that's it. So, that was the demo. And that's what actually Facebook did when they took the web standards and implemented in React Native. They invented this term, Rethink, established best practice as well. Actually not invented, they copied it here. So we've learned from the JavaScript and CSS and web HTML DOM world that we want to keep things separately. So HTML separately, CSS separately, JavaScript separately. Those are different files. We don't mix them, yeah? Do we? No. Somebody likes to mix those three things together? No. But they actually took quite the opposite approach. Yeah? So they are very, very component-centric. Everything which relates to this particular component is in the same place, in the same file, very close to each other. So both, as you saw in the component example, there was some code, some logic, there was a view, how it will look like. There was the style, like how the colors will be and everything in one place. And actually that's good, that's really good. Because now when you work on the component, you can work in one place. You don't have to switch between many different files. Yeah, you can see everything in one place. And that's actually really the way how it should be, not splitting by technologies, by languages, but splitting between like looking and splitting between components. Why they could do that? Because everything in React Native is JavaScript, pretty much everything. Like I couldn't help myself. That's the only animation in this presentation. So things will fly from the right. It's in JavaScript, of course. So the code is of course JavaScript, yeah, as you can imagine. Yeah? Nothing very strange here. The styles, and I'll switch a little bit to IntelliJ here. Those styles, if you look very closely, those styles are JavaScript as well. Yeah, so there is like style sheet, create something, and actually you can write JavaScript code in here, which is quite cool. Okay, views, those views that you show here, those, well, you might think they are XML or something. No, they are JavaScript. I'll show you in a moment. This is pure JavaScript. You don't just don't recognize it. And well, layout calculation. Normally we have CSS in web world, and there is some magic happening to lay out the components. It's in C usually, or some low-level code. In here, it's done in JavaScript. So Facebook wrote their own layout library which calculates the rectangles, how those components will be looking, where they should be put, and it's all in JavaScript. What's really strange about that it's JavaScript that you can transpile to C and Java as well. So you can get the same layout library doing exactly the same thing in Java or in what did I say? JavaScript, Java, and C. Yes. Okay. Good. So you know that presentation, the what presentation of JavaScript. If you don't know, look at it. Not now, please, but after because if you look at it now, you will not be able to continue with the presentation. So don't look at it now. After the presentation. So we all love JavaScript, yeah? We all know how how bad it is. Yeah, do we? Anyone loves JavaScript, likes JavaScript? 1, 2, 3, 4, 5, okay. No, you don't. I do. I actually, I started to learn JavaScript a few years ago, like deeply, 2 years ago or so. And I understand that it's really good. Do you know the book JavaScript, The Good Parts? It's really cool. It's so thin. It's really thin. Like, you can read it in a bus, pretty much going from home to work. But those parts are really good. And really like things about JavaScript, which I will tell you in a moment. So the JSX you saw, I show in a moment. So this is the XML that you saw. Why it's JavaScript? Because actually it is transpiled. Do you know this word? Transpiling? Some people, who knows the word? Who knew that word before? So I've learned about transpiling when I started to learn React Native. Transpiling, it just takes you one source code and converts it into another source code, like kind of compiles it pretty well, not really compiles, transpiles. It's useful, very useful. You have to, when you work with React Native, you often read about transpiling. So that's what React Native does. It actually transpiles those, this XML, like, which is called JSX, and it's, by the way, a standard introduced by Facebook, I believe. So it converts it into something like that. So it creates object, it creates a class, which is here, which actually is a nav class, with some properties, which is like object in JavaScript, and it has a subclass, which is another object in JavaScript. So everything in JavaScript, in React Native, is JavaScript, really. Styles are very cool. They are much better than CSS style because they are predictable, and that's something that CSS doesn't have, and it's a big problem with really big complex code, CSS code. So very much you can see this is an example, very simple style, width, height, nothing special, background color, nothing special. You use it like that. So you simply refer to this style from within the component, and if you remember, these components are JavaScript. So actually you can put some JavaScript code inside this, and that's good, actually. Because you can refer, for example, to styles which are somewhere else, like the common styles that you share between components. You can just refer it directly here. And you know exactly that you're referring to common style rather than guessing that from CSS. So that's really good here. And like here, well, you can compose the styles. Yeah, so we have two styles, a base and background, and you can compose them together. Not that it makes sense, it doesn't, but you can. But what's really cool is that you can actually compose those styles like this. So whenever you render this view, there is this piece of JavaScript. Again, I will repeat many times this word. So the piece of JavaScript executed, and depending on the state, it uses the base style, or it actually adds the active style on top of it, which is quite cool. And it works really well. So, a few words about the JavaScript again. It's not your grandfather's JavaScript. Not that I could be your grandfather, not yet probably, but the JavaScript that I remember from the past. So we can use strict mode, which is actually cool because it prevents you from doing some errors. It uses only 2 runtimes possible. Even on Android, it uses JavaScript core, which is, for me, it was strange. But they use JavaScript core, which was open sourced by, which is part of WebKit, which is open sourced by Apple or kind of supported by Apple. So on iOS, it actually runs on JavaScript core, and on Android, during debugging, it runs on V8, which is in Chrome JavaScript runtime. It uses Node 4.0, and this is actually, every time I do this presentation, I have to change a lot because this React Native is evolving so quickly that things are changing from like within 2 weeks. So I was talking about IO.js 3 weeks ago and 2 weeks ago at the CodePod. Now Node 4.0 and in the meantime was released, and this is Node.js and IO.js converged. They converged a week ago, 2 weeks ago, and 2 weeks ago React Native released a new version when Android was released a week ago actually, and they are already using it. So they are really cutting edge of lots of things. They use some of ECMAScript 6 and ECMAScript 7. If you don't know JavaScript too well, these are new, really cool language constructs that you can use, like lambda functions and stuff like that. And like async await, nice way of doing asynchronous communication. This is really a modern JavaScript version, and you are not tied to like 20 different browsers and versions because you have only those 2 rendering or runtime engines that you run against. For those of you who like static typing, and you are all, well, most of you Objective-C and Java programmers, Facebook also invented something called Flow, which is another transpiling, again. During the compilation of this JavaScript and preparing it for running, you can mark certain pieces of the source code as flow capable, and then you can tell the types of parameters and methods that you have in the code, and it verifies those types. It checks if there are some null pointer, undefined objects inside which are used and stuff like that. So Flow actually helps you find a lot of programming errors during the compilation, not during execution, if you like it. It's optional, you can turn it even per source code or per object, per class, per method, whatever you want. So it's actually quite powerful. So why React is different? Okay, because so far nothing really special. So let me show again this super cool application I developed for CodePod. So we see what happens here. We have like one state, one view, and when I click the application, the component, I treat this screen as single component. It changes the state. And that's the clue about React Native. Because what it does, if you, how many of you know React at all? A little bit, okay, very few. So how React works, it actually, it takes the state of the component, renders it to how it should look like, but does it in memory. So it renders it to an in-memory representation of the views, images, text, as you see. This is the example from my application. So it just builds it in memory, and then based on this virtual representation, it builds the actual native views that represent the application, that are shown in the application. In fact, I'll show you now, just to convince you. I'll do again. So this, what you see right now, this is actually real native application. Yeah? These are standard views here. So that's the image view, that's the text. These are actually components, standard UI views of iOS. But they are backed by this in-memory representation. This is very important. So in memory, they see the whole hierarchy, which is mirroring the views that you see on the screen. So as you saw here, I'm changing the state now. Wow. Okay, switching here. And there is nothing magical here. But React Native does something magical, which actually is the clue of React approach. So it has two states. The first state, that was the state before, two images as you saw before. Yeah? And there is a state after, which is just one image and this clicked text here. Yeah? Once again, yeah, it's cool transition, yeah? So I'll show you again. So you see, what actually happens is that React Native renders in memory the first state, renders in memory the second state, and when you move from one state to another, it actually reconciles those two and only applies differences. And that's the clue. So it only applies incremental differences between those two representations. So you don't worry about state transition. React Native does it for you. If the view disappears, it will just, like in memory, know that this view is disappearing. If there is a new view which appears, it will know that it will appear. If there is a view which moves, it will know that it moved actually. And we can help it a little bit, like we can add some key parameters to help to know which views are which before and after. But basically React Native does it for you. And it actually applies incremental animations. So animation between those state changes. So the whole thing about React, Facebook, the whole idea behind React was like Facebook, with their complex application, they had problem because they had application which was very easy to describe in states, yeah, what happens before the message comes and after. But then lots of things are changing. Like when you get a new message, there is a battery that appears there. There is like a logo of your friend appearing somewhere else and stuff like that. Like things are quite complex in different components. And it's very difficult to manage the stage transition in a consistent way. It's very easy to write state before and after, and React Native actually does all the complex work, most of the complex work, what happens in between. So it's very easy to add animations for those state transitions. So let me do something very, very quickly. I will update to the most recent. Okay, reset all. Okay. So that's the final version of the same application. Or maybe I'll just some animation. Animating. Okay. So I just changed it, and surprise, this is a native application. Remember, we run it from Xcode. I'm just reloading it with Command R, and the application is running. The new version of application. I just changed the code of the application. If you look very closely, you will see some animations happening here. Things are appearing because that's the only thing I told. Like I told the application, if the view in the next transition, if the view is going to appear, it should appear. It's just fade in, and that's the declarative way of telling what should happen. And React does it for me. I don't have to do it. It's just the code is pretty much the same. The only difference is like I put one line, layout animation, next should look like that. The same here, if you see. I did exactly the same thing. So I told, okay, move this, if something changes, then it should move with a spring. And you saw this small animation here. I think it's like slowing down, speeding up and slowing down if you look very closely. And I also told, like this clicked should appear with like scale x, y. It should appear from 0. Yeah. So this state transition I didn't do. It was done for me by React Native, and that's the actually cool thing about that. It knows when things are changing. It knows when things are created. It doesn't yet know when things are disappearing. It is in the code. It doesn't work. So you cannot animate things disappearing in very easy way. You still can do that, but not in such easy way. So there is JavaScript. So how React works is there is JavaScript, which prepares those in-memory representation. There is this reconciliation, which like sees what happens before and after. There are views, which are native, and the question is like, is it fast enough? Well, yes, I think so. Why? Because first of all, no JavaScript is running in UI thread, so they've done a lot of good engineering behind. Yeah, no UI thread JavaScript. Everything is asynchronous and serializable communication, which you can do a lot of cool stuff, which I'll show you in a moment. They are batching the requests, so if many events are happening very close to each other, they will be sent at once between the native part and JavaScript part. Yeah, so there's this bridge between JavaScript and native part is really fast and optimized. They have lots of optimizations, and they designed the whole setup, React Native setup, around the optimization. So some optimizations are not yet implemented. For example, now animations, which I'll show you in a moment, they are mostly done in JavaScript, like animating the properties, moving stuff, and springs, etc. But there is nothing to prevent it to be done declaratively in like native code. It's really possible. It's not yet done because like they didn't have time to do that, but they are doing that. They are preparing for that. And you can use whatever threading model you want. Yeah? So you can control the threads. A few words about animations, and I'll just stop the application that we are running right now and run another one. Because for animations I can talk a lot, but I would rather show you the example they've done. They have this cool UI Explorer application which shows you all the possibilities that you can have with React Native. There's some magic happening here, yeah? Some web servers starting and JavaScript code running, etc. Okay, so this is the UI Explorer. By the way, the red screen of that you showed, it's like very good way of communicating if there are any problems. In this case, it couldn't communicate with the backend server, or well, with the server. I'll tell about that in a moment. So this is the example application from Facebook that they developed to show the new animated thing that they implemented. So all the animations here that you see, they are done in a declarative way. So you simply tell if this particular component is clicked, it should get bigger with spring and get a shadow, and yeah. And when you move it here and here, okay, all these things here are also done declaratively. So you just tell, okay, if this element moves, it should move with a spring. If you see, it's like it's a little bit. It's just not a simple animation there. And by the way, every time when those elements change, the whole screen re-renders. So the whole screen, like the new representation of the screen is built. React Native calculates the differences automatically and redisplays everything, which means that all the all the circles that didn't move, they actually are the same objects which are not changed. Yeah, so, and this is all done in about 20 lines of code or something like that, maybe 30. Now, I don't know if you saw these effects here. This is also done declaratively, like what should happen when things are going up and down. And well, if you see, okay, I'll just put it there. There is this animated, again the same, like you just tell this should increase, just like zoom in a little bit. When you move it a little bit, it should rotate, and the opacity should change a little bit like this. And this is all declaratively done. So you don't write a single JavaScript line of code to do that, or any other code. You just tell it should change like that when you do something. Things like that. Any animation here is probably like 20, 30 lines of code, maybe something like that. Things like that. Again, follow this on Spring. Yeah. So if you know some physics engines, that's very similar. Yeah. Things like this. So, and this works very fast because it's declarative. There is no JavaScript code in the UI thread, and these are all native views. And so, what's cool there is really that this is all declarative. They are working on making it native. Now, like fully native pop animation framework, you know, from Facebook, by the way. So this pop framework will be soon used to do these animations. For now, it's done in JavaScript, the property animations, calculations, etc. But it's from your code, it's done declaratively. Okay, so that's what Microsoft, like Steve Ballmer, did some time ago. But they really think about developers. So whatever you see here, and that's for some of you who develop for iOS and Android, that might be, what you will see in a moment might be kind of mind-blowing, maybe, hopefully. But you can mix and match any kind of native code with JavaScript code. That's the first thing. So you can put a small component which is native inside a React Native application, and you can put a small component, React Native component, inside the native application. You can fully mix and match those. You can have access to native APIs with a very simple, 5 lines, 10 lines of code, and you can access anything that they didn't implement, like map view, wasn't there at the very beginning. It's probably 20 lines of code to access it. Then you can send events from map view. You can, put some objects, some pins on there. This is all very, very simple, and they thought about that from the very beginning. You can access properties of the views directly. This is actually used for those animations to make it faster. So you simply animate the native views directly. You don't re-render the whole screen. And Android doesn't work as well yet. Like Android is behind iOS a little bit because it was released a week ago. So, but they are aiming to to be very, very close. Some questions about developer toolchains that you can use. I'm using, as you saw, IntelliJ, which is good because it has support for this JSX mixing JavaScript and XML, kind of. And now I'll show you some cool stuff which you don't get usually from Objective-C code or iOS code. I will stop the application and one moment, I will restart my application. It will be easier to show. So I have this code.react. Let's run it. Okay, again it waits. It's red screen of that. You will see quite often this. I'll explain a little bit. This application actually uses web server to connect to, which is running here. This is a web server with the JavaScript code. I'll tell about that at the end. So we have this simple application here. And, okay, I will show debugging in Chrome directly. So, simple shaking the device on device or Command D on in simulator. So, okay, debugging Chrome. Let's do some debugging. Cool. Okay. Command Shift. Okay. So you have access, thanks to using JavaScript and modern tools of Chrome and web development, you have access to all the cool tools. For example, now, when I reload that, yeah, I already have breakpoint here. Maybe I'll just do breakpoint here. If you know those, if you know, I'll just, one moment. Okay. It's difficult on such a small screen. Okay, I'll put breakpoint here, so I can click, and I'm already in the break. So this is all fully supported by Chrome. If those tools, Chrome tools for development and debugging are really, really cool, because you can, you know, like, yeah, you can see everything here. You can directly access. It's fairly difficult to do, but you can do whatever you want here and access. For example, this is my React Native object, and I can access it directly from here. Nothing very special so far, but things get better. I'll just start it. Okay. Thing gets better. Yeah. I'll just make this one very smaller. It's really difficult on such a small screen. Just put it away. Normally it is somewhere else. Okay, what do we want to do? I'll enable live. It is already enabled. Live freeload. So what I can do here, let's say, I save it. Nothing happens. Happens. So you can actually edit the code directly, even in the browser, in the debugger, which is in Chrome, and you can see results of it immediately on the screen in the live application. It's not like Playground, where you have copy-pasted piece of code and run it. You can just see it on the live running application, and you can do live reloads and playing with the layouts, as you can imagine, is much simpler here. Yeah, changing here, doing some background changes, color, whatever. Live reloads works really, really fast and beautiful. Plus a React Native guys. Okay, they developed things like extensions. This is extension to the Chrome, which actually shows you the images here, and you can change stuff even without actually reloading your page. So you can very easily play with stuff and very easily change UI parts of it. That's really super cool. Plus, what you have here, of course, you have built-in profiling here that you can use for JavaScript, etc., etc. All the tools from Chrome development tools, they are working beautifully here. Plus, you can have things like inspect element here. Okay, it's probably not gonna be visible on such a small screen. Okay, let me just... The screen doesn't help. Okay, let me just restart it. Okay, I will disable debugging. I will enable inspect. Yeah, so you can see things like this directly on the screen without, on the running live application as well. And they really think about developers. Okay, I shown that. Very verbose error diagnostics, inspections of the element as you show, profiling, support for testing, JavaScript testing, and native code testing, like integration tests and snapshot tests. For now, iOS only, Android not yet. There is this UI Explorer application, which you show as well, which actually shows you all the different... let me restart it. Okay, stop, restart. Okay, so you can actually see all the examples. This is all written in React Native, yeah? So you can, of course, see everything, all the components that are implemented, list views, text input, views, web views, using of accessibility iOS, etc., including this animated app that I showed you. So you have all the examples of things that are working really, how they should be implemented. Few words, it's not very readable, but I'll tell. So a few words about how it actually works under the hood. So you have this, so this is the Objective-C component, Objective-C part, which has a React Native components written by Facebook. They've got the application code, which is native code. You can mix and match native code with the JavaScript code. Some native UI components, which is displayed. And this all goes through a JavaScript bridge, which is really fast and asynchronous and everything, optimization possible. Then your JavaScript code run on some JavaScript engine, like a runtime, the V8 or JavaScript core. And there is always some kind of web server that this JavaScript engine downloads the code from. And this is really useful. I'll show you in a moment what kind of different deployments you can have. So how it works when you have standalone application, very easy. Everything is in the application. You have native code, you have JavaScript bridge, you have the engine, JavaScript core in this case on iOS and Android, and then you have built-in server which serves you the bundle of JavaScript code that you prepared before. Yeah? It's all embedded in the application. That's fairly straightforward, simple. But what happens when you do development? It's a little bit more complex. Actually, this terminal that you saw, and this is like some lines which were printed when we started the application. This is a web server which reads the code from your local file system where you have the code and serves it to the application. So the application connects to your web server, actually, which is running on your machine and reads the code from there. That's why you can do live reloads. Yeah? You can save it. There is a watchman watching it, then informs the code that it should be, informs the JavaScript engine that it should reload the code, it reloads it. Yeah? Then from either you modify it, yeah, so that's how development works at all here. Things get more interesting where you have debugging. Because as you saw, we debugged in Chrome. So actually your code didn't run in the JavaScript engine inside the phone, but it immediately switched to run in the Chrome itself. So there is this bridge, WebSocket bridge, which is standard way how JavaScript can be run on and debugged on Chrome. So this JavaScript bridge, instead of running it on a JavaScript engine here, it actually connects to the code which is running inside your Chrome or Safari, and then you can debug it there, which is pretty cool, as you saw. So what else can you do? You can do even more with that, and that's people started doing it immediately. So you can put your code on like S3, for example, and you can tell your application to load the code not from locally from the bundle, but from this server, like S3 server, for example, which is like just serving the files. And this means that with just copying the files to the web server and giving your customer an application which reads the data from that server, it works a little bit slow because it has to download the JavaScript, but every time it opens the application, it reads the new JavaScript code from your web server, which means that your client customer doesn't have to update the application to get the new version. It's not yet production, but it can be done. Yes?
Is Apple okay with that?
With that, it's no problem whatsoever because you are doing that during development. But then, if you want to run it in production, that's even more interesting because somebody already implemented service called apphub.io, so far only iOS, where your code is actually pushed to Git. They download it there, they make a bundle. A small piece of code they wrote downloads it from your from their server, or yours in the future because they open source that. So download it, stores it locally, and runs it locally from the phone itself. So serves the code that was just downloaded. Yeah, and this runs with a native speed, doesn't download anything while you are opening the application, so it's just production ready, and it works, and you can do that. And Apple is actually quite okay with that in terms of the, it's literally okay according to the rules, because you can run anything as long as it's running on JavaScript core as a JavaScript. You don't have just-in-time compilation. And there is a third condition, you don't change your application dramatically. Yeah, it does the same as it did, maybe with some improvements, kind of. So this last part is kind of strange, or opens the door or closes the door sometimes maybe. But it's okay, you can do that, you can do it now. So you can just release the application to the App Store once, and then make it updated every single minute, hour, how often you want, for bug fixes, for adding small features, not to... Actually, it's possible, if you want, to put new code there and have completely different application running with the same empty shell, which is the application itself, which is cool. What Facebook actually did and what they wanted to achieve with React Native, that's actually, they didn't want to do cross-application platform. Yeah? That wasn't their goal. Their goal was to do learn once, write anywhere. So it means that the same people working in the same team, in their case, their big experiment was the ads manager, which is completely written in Java, in React Native right now, both iOS and Android. So they wanted the same team that knows the domain and developed it for iOS, developed it on Android. Most of the team didn't develop any mobile application before. Yeah? Or they didn't know iOS or Objective-C or maybe even Java. They just wrote it in JavaScript. And they wrote the same kind of code on web before. It's just the same people. The code is, quite a lot of the code is shared. I will tell about that in a moment, but pretty much the idea was that the same people do that. They don't have to relearn new platform. And they actually succeeded at that. And actually, also their goal was that applications are less complex, because React is actually quite good for their approach for applications and makes application less complex because of this componentization, because it's for focusing on small pieces of code at a single time. What they actually achieved, additionally, they shared a lot of code. I think about, they said 60–70% code between those two applications for iOS and Android is shared, which is a lot. They could reuse existing libraries. For example, they have this Rely library, which accesses Open Graph data from Facebook itself. This library was developed for web, and it's like pure JavaScript, no HTML, no CSS, just accessing the data. This was like dropped in React Native, iOS and Android, and it works just like that. So they have some cross-platform support. It's still not perfect. Like there is a big blog post explaining how they synchronize the code automatically over some automated scripts, sharing it between repositories. But they do it in the way that in very, very near future that you can have the same code in iOS and Android in single project. And what they also achieved, and they didn't tell too much about that because of Apple probably not being very happy about that, or maybe, I don't know. But they can do A/B testing. So right now, every piece of the code they have is JavaScript, which I'm betting most of it is or the whole of it is updatable. So they can do A/B testing. They can add new functionalities, new code on the fly, and test with different users. And this is like big goal for iOS and mobile applications in general. Is it ready? It's changing very fast. There are still some issues, small issues, very small issues with performance of animations, for example. But when they're gonna be optimized, they will be mostly gone, I think, I hope. It needs I would like to see that with really big application, because you have to parse the JavaScript, you have to optimize, you have to, parse it and put it in memory, make the engine run it. However, that was my biggest concern when I did this presentation last time, internally in our company in Bolivia. But since then, the next release, they came already with built-in support for splitting the application into smaller pieces and loading them asynchronously when needed. So they are already addressing that need. When I first started working with JavaScript, with the React Native, it was worse because animation didn't work. And the next thing, in 2 weeks, they addressed exactly this problem. So it was like they are following the biggest problems and fixing them very, very quickly. Some components are still beta. There are a number of community components, so people are adding new stuff there. The community is growing. It's not very big. Stack Overflow questions, probably you have like 5, 6, 7 questions about React Native a day, and it grows. I'm monitoring it and answering some of those. That's an easy way, by the way, if you want to get some points on Stack Overflow. Take a new technology, learn a bit about that, and you can earn a lot of points by answering the questions. And you can learn a lot, by the way, as well. Can only recommend it. This documentation is still so-so. So there is React Native, there is React, and they assume that you know React JavaScript before you start going React Native. So lots of concepts are described in React, and they are completely not described but used in React Native. It's like surprise. You can see some examples. What does it do here? I don't know. But then go to the React documentation, React.js, and you find out explanation. And this is kind of distributed. Also, because it's changing so fast, a lot of explanation how things work are in issues in GitHub. And it's like there are lots like animation. There's like the best explanation of how animation works ever in an issue about animation. Go and read that. You will find it very easily. Via the creator of the of React Native, it was like book explanation, long, several pages, very good. You can only find it in GitHub issue, nowhere else, but it's very good. So it's still distributed, but it's getting better. Okay, time for QA. Some things about the company, the way how to contact me, and if you see this on the right side, then there is a reason for that, but go figure out what's the reason. Questions, please.
How are you defining animations in React Native code? Can you show maybe some code, how you did those 2 animations?
Sure. Okay, so all the animations which are described, which are shown here, that's the here. It will not work. Yes, of course, it will not work because I run another application. Mhm. And let me run it again. It's like so cool application. I want to show it and show it again. It's like super cool animation. Super cool application I developed. So here, all those animations that you see. So this appearing, this and that. In the code, those are that's predefined animation from Face. That's it. This is how the things show up on the screen. So showing with the spring, with opacity animation. And that's it for the animations of clicking. Let me show that again. You will be tired of this animation. So there is a custom animation which I developed, and it's defined here. That's about it. That's the whole code. Nothing else. This is the simple way.
Like a CSS style.
Kind of. They've got their own definition of that, like the duration, what happens when you create stuff, what happens when you update stuff. There are those predefined animations defined you can choose from, and you can do much more complex animation like those which you show. So in the Facebook code is a little bit more complex. I can show you this code as well. Okay, it should be here. In the meantime, if somebody has another questions, you can ask. Yes?
So my question, does this React mean? I'm
Good.
shocked. So does it mean that front-end developers suddenly start writing code in mobile apps thanks to React Native? Or native developers are still in front of that because we know our ways around Android or iOS?
Yeah. So does the front-end developer will start writing? Those who know CSS and HTML, they have nothing to do in React because there is no CSS and HTML. There is only JavaScript. So those who can know JavaScript, they can very quickly write mobile application for iOS and Android without knowing a lot about what's inside. And without learning Objective-C, without learning Java, they won't be able to do everything. You sometimes have to develop custom components or like simply know how things work and learn how this works. But this helped actually Facebook to get like very small group of people who know iOS, Objective-C and Java to work together with lots of people who know JavaScript and developed this type of application before, like ads manager application. So they knew everything about the application, about the domain, and they implemented that. So it's possible, yes. Those guys who implement that ads manager, most of them didn't and still do not know a lot about Objective-C and Android UIKit. No, you don't have to do that. I'm not an iOS developer, and this beautiful application, small, I developed it like fairly quickly. Yeah. And people could actually do that during the workshop, so go through the number of steps. And this application is actually more complex. I can show you because it downloads workshops from CodePod and displays them, so it's more complex, really, a little.
I wanted to thank you for a very good presentation. I enjoyed it very much. And I wanted to ask about the styles. What sort of CSS is it? Is it what we have in browser or some subset of it? I'm asking because I saw that you created a flex box. There is a flex 2.1.
Okay, I'll tell you just flex. So where is it? So it implements actually from CSS, it implements only very small subset. So no insane defaults, no baggage, no these strange things and behavior, how it behaves. It actually only implements flexbox from the layout point of view, plus all like width, height, colors, background colors, etc. etc. So Flexbox, it's fairly easy. I will not show you. Actually, the Facebook, Facebook implemented, that's this. So they implemented this. This is this project that is actually used by Facebook to lay out the screens. You feed it with these objects describing the CSS, which is like JavaScript object, and at the end you get, for every component, you get the rectangles where they should be. It calculates it. So this is this JavaScript library they developed. And as I said, this JavaScript library transpiles to C and Java as well, using regular expressions. You don't want to know, really. It's brilliant piece of code. So they developed that, and it's only a small subset, and it's described here what is actually supported. Yeah, so it's not even full Flexbox implementation. It's simple version of it, let's say. But you can do pretty much everything, and you can, at the very end, you can absolutely lay out things on the screen as well. So you can calculate those in JavaScript positions and sizes and put it in there. It's easy. You have to be close.
So I would like to ask you for opinion about React Native. Is it, like, in your opinion, more for people that don't know Objective-C or Swift and like to start writing mobile application? Or perhaps is it, in your opinion, better to like switch from Objective-C or Swift or whatever native language it is? And in general, do you think that it's like good to start with React Native right now, or perhaps is it more like a proof of concept for now?
It's certainly, if you know Objective-C or Java, Android Java, and you're proficient with that, then you can do more and faster, probably, if you've learned and have an experience than in JavaScript, initially at least. Because you don't know JavaScript, probably, most likely, yeah. So, but once you learn it, you can work much faster with this web workflow, you know, auto reloads and like changing stuff and seeing the result immediately. Definitely, if you don't know iOS and Android, you can start writing React Native applications, and it's better for those guys because they know JavaScript. If you know React, it's even better because it takes a little bit of learning how the whole React pattern works. And it's you can definitely do that. So answering the other question, if it's production ready, Facebook released already 2 applications, like the Facebook Ads Manager and part of the groups. The groups are actually mix of native and JavaScript code, and they won't tell you which is which, and actually they challenge everyone to guess, and you cannot tell the difference really. So you can actually write production application in React Native. Android probably not yet, like it's very, very fresh, but iOS is there already for some time. And it's stabilizing. You can see that it actually is stabilizing and getting better and better. So if you have a low-risk project that you can survive some like quick changes, is like a bit like Swift some time ago when it was like really changing very fast. So it will break things, but you can fix them very quickly if you know JavaScript well. So yeah, we are actually talking to our customers and trying to find a nice small project that we can start in React Native. We haven't done a production version yet. It was just my playing and a few other guys looking at it, but that's pretty much it.
Could you bring the IntelliJ window on top?
Sorry?
Could you bring the IntelliJ window on top? I want
Yes.
to see the code.
Yes.
Because I'm curious about that embedded XML.
Yes.
You told us that this file is pure JavaScript.
Yes.
It should be run as JavaScript, or should it be transpiled?
It is transpiled automatically, but
That's my question.
while the server is serving the code, it actually transpiles it, checks the syntax correctness, etc. So it's not actually. If you really want, you can write those views in JavaScript. You don't have to use these JSX and XML. You can actually write everything like create class, add property, etc. But it's much more convenient to do it this way. Okay, thanks. I'm here afterwards, so we can ask any questions afterwards. Thank you.